Hi everyone, here it is given a welt of negligible mass passes between the cylinders A and B and is pulled to the right with the force P. Cylinder A and B having the weight.
Here's a clean and
Weight
professional
of
formatted
cylinder A is
presentation of the
given
calculation shown in
5
the
pounds
image.
and that of B is given
Application of the work energy theorem, WET. From the
20
work
pounds.
energy theorem, the force F is given by
Radius
F
of
equals
A
frac
is
times
given 4
KE,
inch
where KE equals
and
kinetic
radius of
energy,
B is
S
given
equals
8
stopping
inch.
distance. If I'm given for object A, FA equals frac
The
100,000,
shaft of a cylinder
0.10.
A is free to
For
slide
object
in a
B, FB
vertical
equals
slot
frac
and
225,
coefficient of
1500 equals
friction between the belt
0.15 text
and
makes N.
each
And
cylinder.
force ratio frac FA, FB equal frac
Nu S
0.10,
is
0.15
zero point
equal
0.5
fractional result. A box frac
and nu
FA,
K is
FB. Would you like a
zero point 0.4.
PDF version of this explanation?
If force P is 3.6 pound, then calculate whether slipping occurs between the belt and cylinder. B part. Angular acceleration of both. Let us start solving. Assuming no slipping, we are assuming here that slipping doesn't take place, then acceleration of belt will be alpha A into Ra or alpha V into Rb. Ra is of 4 inch, so 4 alpha A is equal to 8 times of alpha V. So from here we can conclude angular acceleration of A is 2 times angular acceleration of B, or angular acceleration of B is half of that of A. Say first equation. Now for cylinder A, see here, this is the cylinder A. Its weight will act here. Normal reaction. Fa. So if we find moment by considering anti-clockwise to be positive, to be Fa into Ra to be IA into alpha A. FA radius is given 4 inch, so 4 by 12 feet. Moment of inertia is half mr square. Half mass is weight is given, so convert into mass by g. G we will value later on we will substitute. We will finding the answer in terms of g into 4 by 12 whole square into alpha a. So from here you may find Fa to be 5 by 6 alpha A upon G, say equation 2. For cylinder B, this is B. Normal reaction, force B. Now calculating moment of force in clockwise positive summation of moment of force about V. You can find Fv into Rv to be Iv into alpha V. Fv Rv is given 8, so it will be 8 by 12. Moment of inertia, its mass is given, its weight is given 20, so 20 by g into half mr square, so radius is 8, 8 by 12 square into alpha v, and it is half of alpha a from equation 1. So on solving it, this would be written as, let us write it this properly, otherwise you will get confused. That is 8 by 12 whole square. So on solving it, this equation will give you force on V to be 20 by 6 alpha A divided by acceleration due to gravity. This is your third. Now see the motion of the belt. On the belt, forces. Summation of force on belt we are finding in this direction to be taken positive. You will get P minus Fa minus Fv to be 0. P is given 3.6, Fa is 5, alpha A upon 6g. Fv we have found 20 by 6 alpha A upon g is equal to 0. So from here alpha A you will get 0.864 into g, and g is 32.2, so it would be 27.82 radian per second square. Now Whether we have to check whether the belt slip or not from equation 2. We can write force Fa to be 5 by 6 into alpha A, that is 27 point. You will get 0.72, 0 pound, and from 4 force on B we can find 2.88 pound, but friction available mu s into n, mu s is 0.5 into 5, that is 2.5. Since force on just a moment, since force on E that I have done wrong interpretation, let me correct it. Since force Fe greater than Fm, so assumption is wrong. That is, selfing occurs between the disc and belt. We will redo the analysis in case of selfing. In case of selfing, alpha V is not equal to half of alpha A. For friction on B will be mu k into N, that is 0.4 into 5, that is 2 pound. So for disc B, you can see Fp. This is normal reaction. Now find the moment about B point. Fp into Rb 2V, IV into alpha V. This is 2, Rv is 8, so 8 by 12, 8 inch actually. So it has to be used in foot. Moment of inertia, its mass mr square, weight is 20, that is g. into radius is 8 by 12 square into alpha v. So by solving it, you will get alpha v to be 9.66 radian per second square. So this is the angular acceleration of v. Now we have to find velocity. From Welt equation 4, P minus Fa minus Fv is equal to 0. So force on A will be P minus Fv. P is 3.60 minus 2, so it is 1.60 pound. So since Fa is less than friction force, so there is no slipping between disc A disc and belt. So equation 2 is valid for it. So using equation 2, we can write 1.6 pound to be equal to 5 by 6 alpha A upon G. So from here alpha A you will get 61.8 radian per second square. That's all for this problem. Thanks for watching it.